In this video, we are going to learn how to balance a chemical equation. Now, let us consider an example of an acid and a base reacting to give salt and water. Let us take the example of sodium hydroxide and we'll take sulfuric acid. What will we get? We'll get sodium sulfate, which is a salt plus water. The first step is to write a reaction using the formula of each of the reactants and products. If we see, these are called the reactants. They are reacting to give these products and it is indicated by the arrow mark indicating the products. Now, let us write the formulae for sodium hydroxide. This is step 1. So, step 1 we have to write as sodium hydroxide plus sulfuric acid. The formula of sulfuric acid is H2SO4 gives us sodium sulfate, Na2SO4 plus water formula is H2O. So, we have done our first step of writing all the reactants and products with their formulae. Now, what are we required to do? We have to write down the number of atoms of each and every element present in this reaction. Now, the step 2 is, let us do this. Elements and number of atoms on LHS, here on RHS. This is how we have to form a table so that we can easily identify whether the equation is balanced or not. First one we'll take as sodium. Sodium on left hand side is 1. So, 1 atom of sodium on left hand side. Here you have 2 on product side. Now, let us write about oxygen. Oxygen 1 plus 4, total 5. On product side you have 4 plus 1, 5. Now, let us write hydrogen. Hydrogen, how many we have? 1 here plus 2 here. So, 1 plus 2 equal to 3 I am writing here. And here you have 2. So, I am writing 2 here. Now, the remaining is sulfur. Sulfur 1 on LHS and 1 on RHS. Now, let us try to balance this equation. First, we have to start with sodium. Sodium, you have only 1 on LHS. So, I will be multiplying with 2 here. So, this 2 belongs to the whole NaOH. That means, now you have, instead of 1, you have 2 sodium atoms on LHS and 2 sodium atoms on RHS. Now let us see about oxygen. The number of oxygen has increased. So instead of 1 here, I have to write 2. So how much it has become? 6 on LHS, and on RHS side you have only 5 oxygens. Now hydrogen has also changed because I have written 2 here. This belongs to sodium, oxygen and hydrogen. Therefore, number of hydrogen atoms on LHS has changed. I have to write 2 plus 2, which is equal to 4, and here I have only 2. The remaining all are same. So, if you compare, sulfur is balanced, sodium is balanced. Now, hydrogen and oxygen are not balanced. Now, if you see, this is 6 and this is 5, and here you have 4 and 2. To balance this is very easier. So let us try with this one. You have double the amount on LHS than that in RHS. So I am writing 2 here. What happens? Now the hydrogen has increased 2 times. Therefore, 2 into 2, which becomes 4. Now let us see about oxygen, how it has brought change in oxygen. You have 4 here, so 4 plus, and what about the number of oxygen atoms here? 2 into 1, which is equal to 4 plus 2 is equal to 6. So on RHS side, I have 6 oxygens, and on LHS side also I have 6 oxygens. So oxygens are also balanced now. So sodium is balanced, 2 and 2. Oxygen is balanced, 6. 2 plus 4, 6. 4 plus 2, 6. And hydrogen, 2 plus 2, 4. 2 into 2, 4. So hydrogen is also balanced. And then one sulfur atom here and one sulfur atom here. So the whole of the equation is balanced now. This is how we have to balance an equation step by step in a systematic order. At last, the major important thing we have to do is tally the number of atoms on LHS and on RHS. If both of them are same, then our balancing has completed. So, I'll write the balanced equation now. So, the balanced equation is 2 NaOH plus H2SO4 gives Na2SO4 plus 2 H2. One more important thing we have to remember is that we have to reduce the coefficients, that means these coefficients, to their smallest whole number values if necessary, or if possible by dividing them all by a common divisor. For example, I'll do this. If you have 4 NaOH plus 2 H2SO4 gives 2 Na2SO4 plus 4 H2O. In this, if you see, you have 2 in common. So, what are we required to do? We have to reduce this to smallest whole numbers. That means we have to divide whole of this equation with 2. So, we will be getting which is the correct one. During balancing, if we get this sort of equations, we have to see the common divisor and then we have to bring it to the smallest whole number coefficients. But for this equation, this is the balancing of the given equation to us. Okay? In the next video, we'll learn more examples related to chemical equations.